Hello, I'm Richard Patterson and I'd like to welcome you to Series 2 of our science videos presented by IPC Irwin and CPE Science. And in this episode, we're going to look at the second of the gas laws. In Series 1, we looked at Charles' Law, so it's now the turn of Boyles' Law. And we've got this familiar Boyles Law apparatus for you here, and we'll just take you through the setups points for this, and then we'll do an investigation into Boyles' Law. So, as you can see, the apparatus is traditional. It's got a reservoir at the bottom here in the base, and this is filled with an amber-coloured oil. You can fill the oil up if needed by removing the valve here, which is connected to our bicycle pump. There is a valve inside there, and if you want to reset the pressure within the Boyles Law apparatus, you can unscrew this and just press momentarily the rubber valve and it will equalise the pressure. We measure the pressure using this Bourdon gauge or pressure gauge, and that is calibrated in kilopascal. And at the minute it's reading I forget 165 kilopascals on air. Now there are ways to adjust for if you're doing this above sea level. I think that you need to add up one kilopascal for adjustment if you're above sea level. But we're by the sea now where we're filming, so that doesn't apply. So let's see if we can increase the pressure. Before we do that, it's useful to remind the students of what we're trying to investigate. If we give the students a simple syringe and ask them to hold over the nozzle there, we could do a little simulation of the Boyles Law. As we press down on the plunger there, we're compressing the gas, and we should be able to feel the gas pressure pushing back on that nozzle as we move the syringe down the barrel there. There's also a very useful animation provided by NASA's Education Department, which you could see here following this link. So let's have a go at taking some measurements. So the students need to be aware of the variables here. A gas has a temperature, a volume, and a pressure. And in this experiment, Boyles Law, we're keeping the temperature constant. We're assuming for the duration of the experiment, the temperature is going to change. The independent variable is going to be our pressure, and we can change that by using the bicycle pump here. And the dependent variable is going to be the volume of the gas. So in the 1600s, a scientist by the name of Robert Boyle performed this experiment, and he wanted to look at the relationship between the pressure and the volume of the gas, that constant temperature. And he observed that as the pressure increased, the volume decreased. But he noticed from his readings that the product, that's pressure reading multiplied by the pressure reading, was always a constant. And we're hoping to get somewhere close to that when we do the experiment now. So I've now increased the pressure up to its maximum value of 250 kilopascals on the gauge there. And the gas has been compressed and is now on the scale 24. So what we're going to do now is gradually release the pressure by unscrewing the pump and gently releasing the valve. So I'm going to take readings as I hold there. So I've now got the volume to 25 and the pressure has dropped to 240 kilopascals. So I'm going to repeat that procedure until we get down to our starting point. Now, if you're doing this in the lab, remember we've got a parallax error, and we should be reading to the bottom of that meniscus of the oil. But and I'm facing the camera behind the equipment, and that's going to be difficult for me. So I'll just release the pressure again, and we have got quite fine control there. I'm just tightening up the valve and locking it off so we don't lose any more pressure. So we're now down to up to 26. And the pressure is now at what's that? 225 kilopascals. So repeat this procedure every unit of volume, like so. So now I'm back at the starting position, and I've got a table of pressure and volume readings, and I'm going to plot those on a graph. Remember, pressure is the independent variable, so I'll be plotting that along the x-axis, and volume is a dependent variable, that's be done along the y-axis. And if your students have got access to a spreadsheet, very straightforward, you just put those into a table and then graph the two sets of the two columns of data. So the graph of volume against pressure should be a reciprocal curve, and if we plot a second graph, we'll plot it pressure against the reciprocal of the volume, we will get a straight line following Boyles Law that the point at the pressure and the volume is equal to a constant. Just a couple of points about safety. The dust tube is extra strong. If it was to break, then there's a toughened plastic screen in front of it. So thank you for watching this demonstration of Boyles Law. As ever, if you use our QR code, you can get the instructions and teaching materials on our website. Please refer to the Institute of Physics Spark site for a more detailed set of instructions and some teaching notes. And lastly, please subscribe to our YouTube channel and our monthly newsletter.